My name is Natalie Rakowski, and I am a student at Georgia Institute of Technology, and this is my post-lab quiz tutorial for my Physics 1 class. Today we will be discussing the momentum principle and gravitational interaction. So here's the situation. The NEAR spacecraft, with mass 805 kilograms and velocity of 10,000 meters per second in the x direction, flew by the Methyl asteroid with an adjacent distance of 1.2 e to the 6th meters. Today I will explain how the gravitational force of the asteroid will affect the path and velocity of the spacecraft. First, I will draw a diagram, then discuss the physics from a fundamental principle and make predictions, and then finally simulate the situation using VPython software. Momentum in a system is always conserved. That is why it takes an outside force to affect the momentum of an object. This is also known as Newton's first law. The increase or decrease of the momentum is equal to the magnitude of the force over time. For the gravitational interactions of interstellar bodies, the formula to the right is given. F of g is force of gravity. Notice that distance is a factor of the force for gravitational interactions formula. Because of this, as the spacecraft moves away from the asteroid, the magnitude of the force acting on it will decrease. Due to the fact that the force would decrease as the distance increased, the best way to calculate the exact change in velocity and course will be through simulation. Therefore, I will first make predictions on what will happen based off the diagram. If no force acted on the spacecraft, the velocity would continue to be the same and the course would not be affected. Due to the force of gravity on the asteroid, I predict that the x direction of the velocity will decrease and the spacecraft will decelerate, and the y direction of the velocity will also decrease. This is because the force of gravity is negative in the x and y directions. Notice how I drew small arrows by the red arrows. These yellow arrows represent the force of gravity by the spacecraft on the asteroid. Because the spacecraft is much smaller than the asteroid, it does not affect the asteroid as much. In fact, it is so small that it does not even need to be considered. Now I will show you my simulation in VPython. Similar to my diagram, the green line represents the unaffected course of the spacecraft, and the yellow line represents the affected course. Notice how it is similar to my diagram. Now I will tell you about my VPython code and how it works. The loop you see calculates the spacecraft's momentum 1 second at a time. I chose to run it for 1 day, or 68,400 seconds. In the red box, notice how the fourth line of the code calculates the force of the asteroid's gravitational interaction. The fifth line of the code updates the momentum using the momentum formula. And the sixth line updates the position using the velocity. Now I will compare my initial values and the final values from the simulation to my predictions. If no force had acted on the object, the velocity would have stayed the same and the object would have stayed on course in a horizontal line. Due to the interactions, because of gravity, the x and y components both decreased, and after 1 day, or 68,400 seconds, the spacecraft would be 3.84 e to the 7 meters off course. Thank you for watching my presentation, and have a wonderful day.